So now this question is related to electric field at point P. So I have a ring and this ring contains a charge Q. Radius of ring is given to you. So this is A. A is basically radius of ring. So this is radius of ring. Now the question says the distance from center to P is x. Are you getting or not? We have to find what is the electric field at P, and we have to investigate what should be the distance x so that I will get the maximum electric field at P. And now to discuss this problem, we will not derive the result. In class we have already derived the electric field at P will be Qx divided by 4 pi epsilon naught a square plus x square raised to the power 3 by 2. So this is the result we have already derived. So electric field basically at any point x, electric field is given by this function on the perpendicular axis, that is a perpendicular to the ring. So this on this axis at a point P, electric field is given by this equation. Now the question says find the maximum strength of magnitude and corresponding distance x. You see electric field is a function of x. So if I change x, electric field will change. So I can always get a electric field that is maximum for a given x. So what I have to do is I have to find maximum of this electric field, that is dE by dx is equals to 0. Now this term is a constant, so I have to only differentiate this one. Are you getting or not? So let us try to do this differentiation. So E is equals to this term is a constant x, and this divided by E square plus x square to the power 3 by 2. So let us do this differentiation. So dE by dx. So I have to leave the denominator. So let us differentiate this u by v. So let us, if I differentiate, so first I have to leave this one, and then differentiation of x is 1 minus differentiate this one. So this is 3 by 2 and root over a square, 3 by 2 minus 1, that is a square plus x square, and then differentiation of x square is 2x, and then I have to write this whole square. So this will be a square plus x square raised to the power 3. So this is the differentiation. I have to plug this is equals to 0. So if I equate this with the 0, so I will have this side, you can do yourself, a square plus x square. This is equals to, so this 2 to go, so 3x. Are you getting it? So this side, I think, am I doing some mistake? Yeah, in this case I have to leave x also. So I have to leave, so initially I have left this and differentiated x. Now I have to leave x and differentiate this one. So I will have 2x square here. So I will have 1x square. So from here I can write a square is basically equals to 2x square. So x is nothing but a by root 2. So I can say the value of x is a by root 2. Basically we'll have plus minus a by root 2. So this has a meaning. So either you can take this side a by root 2, or you can take this side of the ring, that is minus a by root 2. Now we have to find what is the electric field you will have. So electric field in this case you will have, that is given by Q, x is a by root 2, this divided by 4 pi epsilon naught a square plus x square. So a square plus x square is a square by 2 raised to the power 3 by 2. So this is the electric field you will have. So Qa by 4 pi epsilon naught root 2, and this will be a square, so 3a square by 2. So here you will have 3a square by 2 raised to the power 3 by 2. Are you getting? So if you do some more massaging of this equation, you will have Qa by 4 pi epsilon naught root 2, and this root 2 goes on the top, so we will have 2 root 2, and here we will have 3 root 3, and this aq is simply aq, so we will have root 2 cancels out, so this root 2 cancels out, 2 cancel out, so we will have 2 into 3, 6 root 3, so in the denominator we will have 6 root 3 pi epsilon naught. You can do your calculation your own, q, and this a also cancels, so we will have a square. So this is the maximum electric field that is possible at the axis of a ring. In this side, if you have, so this side you will have, if you have to find this side, you have to take x equals to minus a by root 2. So only thing is we will have negative sign. So negative sign shows this side of the ring electric field will be directed in this way. This side this will be directed in this direction. Now question also says, can you plot this electric field as a function of x? So let us say this means what? I have x this side and I have electric field this side. So for x equals to 0, electric field is 0. You can check here itself. When x is 0, electric field is 0. X is 0, electric field is 0. So x is 0, electric field is 0. Initially it will increase and then it will decrease. And finally when x is infinite, so when x is infinite, what will happen? When x is infinite, this term will be governed because this is x and this is x square. So this is a bigger term. So this will be finally goes to 0. Now if you plot for negative side of x, in that case electric field will be negative. So negative side of x will have this kind of graph. Are you getting or not? Because negative side of x, electric field is negative. Negative means this is directed towards minus x-axis. That is the only meaning we have. So this is the maximum electric field we will have. And here this is the maximum electric field. Only thing is sign is different. This means the direction are different. In one case, if the ring is this, I have taken this as the x-axis. This side electric field is directed in this way. This side of the ring electric field is directed in this way. Only the difference I have. The distance from the center, maximum distance is a by root 2 in both cases. Either you have this side or you have this side. Are you getting? Basically if you want you can check this result. So result is qx by 4 pi epsilon naught a square plus x square raised to the power 3 by 2. You can verify this result for limiting case, that is x is much greater than a, that is very far away from the ring. If x is much greater than a, in that case either I cannot add this a square with respect to x square. So I can write electric field will be qx divided by 4 pi epsilon naught a square. I cannot add because this x is much greater. There is no meaning to add. So this is simply x square raised to the power 3 by 2. So this is x cube. So x will be cancelled. So we will have q by 4 pi epsilon naught x square. So you see this becomes a point charge, electric field due to point charge. And that is very true. If you go up to infinite, ring will look like a point charge. And that's why when x tends to infinite, even either positive infinite or negative infinite, electric field tends to 0. And that's why in my graph I have shown something like this. Electric field tends to 0 when x tends to infinite. This side also electric field tends to 0 when x tends to minus infinite. So this is very obvious. Are you getting or not? We'll discuss the next problem. I think all of you have copied this one. If you have not copied, let us copy fast. And then we'll discuss the next problem. Quite good problem. We have not derived the result, that is the initial result qx by 4 pi epsilon naught a square plus x square raised to the power 3 by 2. This you can derive yourself, or we have already derived in the class. So let us discuss the next problem.